Campi Flegrei stretches 125 miles under urban areas and out into the Bay of Naples. It's often called Europe's most dangerous volcano.
Beneath Naples, temperatures are rising where they should not. Campi Flegrei is heating up faster than expected, and instruments are recording changes that worry scientists. The streets above look normal, but the ground below is not. Why is this heat increasing now? What does it mean for a city built on it? Let's examine what is happening under Naples. The rising heat of Campi Flegrei. In Puy Aguino and the surrounding Sulfatara region, residents started noticing a strange and concerning change. It wasn't abrupt or noisy, but it was undeniable. Houses were gradually getting warmer on their own, not because of heaters, summer weather, or electrical issues, but due to heat coming from the ground. Residents observed that the floors in their homes felt unusually warm, even late at night. Some noticed that their ceramic tiles felt softer than usual. Others found that their basements, typically cold and damp, now felt like furnace rooms. Families made adjustments to cope with the heat, such as relocating their children's bedrooms to cooler areas. These experiences were not unique, as similar stories were shared throughout the neighborhood. Independent thermal cameras quickly verified the heat that people were sensing. The heat maps displayed glowing city pavement that looked as if there were fires burning underneath. The roads, sidewalks, and courtyards all had intense heat readings that were unusual. This wasn't just one isolated hotspot, but rather a widespread issue throughout entire neighborhoods. Officials initially attempted to alleviate concerns among the public by describing the changes as bradyism, which is the gradual swelling and sinking of the ground that Campi Flegrei has been renowned for in the past. This natural phenomenon has affected the region on numerous occasions. However, the current situation was not consistent with the usual explanation. The intensity of the heat was unprecedented and spreading at a rapid pace. Additionally, the pattern of movement was unlike any previously observed cycles. The events were outside the realm of normal bradyism. This led to a more important question. What was causing so much heat to rise up into the city? In order to grasp the risk, it's crucial to know what is beneath Naples. Campi Flegrei isn't just one volcano like Mount Vesuvius. It's a larger and more intricate system. It's a huge underground volcanic structure that spans about 15 kilometers. This structure is a massive volcanic caldera formed by two incredibly powerful ancient eruptions. Around 39,000 years ago, the first eruption occurred, which was one of the most violent events in European history. It spread ash across a large portion of the continent and changed the landscape permanently. The second eruption happened around 15,000 years ago, shaping the large depression that we see today. This depression is now inhabited by nearly 3 million people. Cities, roads, ports, and neighborhoods all exist within this ancient volcanic structure. For centuries, Campi Flegrei has not been inactive. It has been slowly building up heat, gas, and pressure underground. The system has been quietly active instead of completely still. Scientists have observed signs of increased activity over the last 20 years. Small changes like movements in the ground and minor shifts have been noticed. These changes can still be explained by what is already known about the behavior of the area. 1 year ago, there was a sudden and unexpected change. Data from satellite radar indicates that Campi Flegrei has been gradually rising since 2005. The increase was steady over time, but more recently, the rate of rise has significantly increased. The uplift has tripled in speed. Sections of Puzui are now visibly higher than they were previously. This is not just a theory, as it can be easily observed with the naked eye. Old docks that used to be at sea level are now higher than the water, separated from the shore. Buildings meant for the sea now awkwardly float, like things left by the tide. These changes show movement beneath the surface that is permanent. With each rise of the land, there are new consequences. These consequences are caused by earthquakes. In the past few years, over 50,000 small earthquakes have been detected in the region. While these quakes may not be powerful enough to cause damage to buildings, they are significant because they create small fractures within the Earth's crust. These fractures create tiny pathways that were not there before. Scientists use the term chimneys to describe these pathways. Chimneys are openings or cracks in the Earth's crust that release heat and gas from deep underground. With each new chimney that forms, the barrier between the magma system and the surface gets thinner. The crust essentially acts as a lid, keeping pressure contained. But as it weakens, this lid is less effective at holding back what lies beneath. The crust getting thinner could be the most risky change happening. Pressure always looks for a way out. When the lid weakens, pressure looks for new paths upward. This doesn't just cause the ground to move, but also leads to changes in what is released into the air. In the past month, the gas emissions in the caldera area have changed in how strong and what they are made of. The vents used to only give off warm air, but now they release very hot steam. The power of these emissions has gotten stronger. Devices placed around the area started picking up on new types of chemicals being released. Hydrochloric acid, carbon dioxide, and hydrogen sulfide are currently flowing into nearby neighborhoods. These gases are not staying contained in vents or open fields, but are spreading through streets, homes, and public areas. The impact is quickly noticeable. Metal handrails rust overnight as their surfaces are damaged by the acidic air. Outdoor fixtures deteriorate more rapidly than anticipated. The environment is showing signs of strain. Animals are the first to react when exposed to fumes. Pets may start vomiting after being exposed to the fumes. People can wake up with burning eyes and irritated lungs after exposure. Breathing may become difficult and uncomfortable. The air may feel heavy and sharp to those affected. These symptoms are real and not just in their heads. These symptoms are consistent with the gases being detected by sensors. Each of these shifts indicate the same ending. The system underneath Campi Flegrei is becoming more permeable. Heat, gas, and pressure are moving upwards more easily than in the past. When the ground begins to glow, passive infrared scanners are typically quiet and simple devices used by engineers to locate heat leaks in buildings. These scanners are meant for routine inspections rather than for alerting to emergencies. However, they are now uncovering troubling findings, patches of heat appearing on sidewalks, in courtyards, and on driveways throughout the city. These are not isolated incidents, but rather widespread occurrences on the urban landscape. This is not a normal occurrence and should not happen in a stable city environment. Heat is no longer contained in its usual places, like volcanic vents or deep underground cracks. It is now moving up through the city, with streets and residential areas showing unexpected signs of warmth. This surface heat indicates a big change has happened underground. When heat comes up to the surface like this, it means something has disrupted the balance beneath the earth. Beneath every volcano, molten rock called magma is usually contained beneath a solid layer of rock. This rock acts as a lid, trapping pressure, keeping gases inside, and slowing down the magma's movement. This barrier is crucial for keeping the volcano stable, even when there is activity deep underground. Issues arise when the strong barrier begins to deteriorate. Cracks appear in the rock, and even small fractures can have an impact. Once the rock is no longer intact, pressure is no longer contained. Gases that were trapped inside the magma now have a way to rise up. They start to leak through these cracks, moving towards the surface. As gases are released from the magma changes and becomes lighter and more buoyant. Without the gases trapping it down, the magma starts to rise quicker. This process is familiar to volcano experts and is often seen before large eruptions. The release of gas, the ascending magma, and the rising surface temperature follow a predictable sequence that has been seen numerous times. The current observations by scientists closely resemble a specific pattern. The rise in surface temperature, movement of gases, and shifts underground all line up. This is why experts are closely monitoring the situation. It's not just one signal that's worrying, but the occurrence of all signals together. Researchers are looking at how things are now and how they were in the past, specifically when the volcano erupted in 1538. This eruption caused a new volcano called Monte Novo to form. Before the eruption, there were many earthquakes for weeks. Then the ground started to get really hot all of a sudden. Steam shot out violently. In only 7 days, a new volcano was created. The land completely transformed in just 1 week. Monte Novo, on the other hand, was not very big. Its eruption was not as widespread as the larger volcanic system below it. Campi Flegrei is much more powerful. Geologists have evidence of this from past events and the records of the Earth. The volcanic system beneath Campi Flegrei is bigger, hotter, and can withstand more pressure. What makes the present scenario more dangerous is that this system is under a modern city with a lot of people living in it. This time, the situation seems more serious. The heat readings are more powerful. The pressure readings are elevated. The affected area is larger. Instead of being an open land, there are buildings, schools, hospitals, roads, and important infrastructure above. All of these are directly above a volcano that is showing signs of stress. The main concern is what would occur if the rock covering fails now. If Campi Flegrei erupts, the first signs would probably be explosive eruptions caused by heated groundwater. This happens when water meets rising heat underground. Water turns into steam very quickly when it's suddenly exposed to extreme heat. The steam expands violently, with force pushing outward and upward. When this occurs, the Earth's crust breaks. Pieces of rock are thrown into the air. A cloud of ash shoots up quickly into the sky. The blast creates waves of pressure that spread outward from the eruption site. In a city setting, these pressure waves would travel through buildings, streets, and open areas. The noise and force would be very strong. After the first explosions, there would likely be pyroclastic surges. These are very dangerous volcanic events. They are quick-moving clouds of gas, ash, and debris. Their temperatures can reach over 400 degrees Celsius. They do not move slowly, but instead rush across the ground as fast as hurricanes. Anything in their way is quickly engulfed. Buildings are not made to withstand this powerful force. Pyroclastic surges destroy buildings, remove everything from landscapes, and do not give people enough time to escape. Whole neighborhoods could be swallowed up in a matter of seconds. The danger is not just from being directly hit by the surge. The intense heat alone can be deadly. Ashfall from the volcanic eruption would cover a large area beyond the blast zone. The fine ash would land on surfaces like roads and roofs, as well as open spaces. Depending on the wind, the ash could travel to the airport, highways, and even areas outside the city. Under certain circumstances, ash clouds might move over parts of Europe. Naples has a natural, amphitheater-like shape with hills and ridges all around it. This unique geography affects the way shockwaves travel. Unlike spreading out evenly, the pressure waves can be channeled and bounced between the ridges, making their impact stronger in some places and causing more destruction. The impact would go beyond just buildings and structures. Transportation systems would be immediately affected. Debris and ash could make roads impassable. Rail lines might get damaged or covered in ash. Airports would probably close due to unsafe flying conditions caused by ash clouds. Power systems could also be at risk. Ash has the potential to interrupt electrical equipment, block ventilation systems, and trigger short circuits. Communication networks depend on both power and physical infrastructure. If there is a power outage, communication would be affected as well. During a crisis, this lack of communication would make coordinating efforts very challenging. Scientists point out that the biggest threat might not actually be the volcano erupting. The most crucial time could be the moments right before it happens. These moments are crucial because they can decide if people are able to escape to safety or end up getting stuck. The Italian agency in charge of civil protection knows about the dangers. The alert levels have been raised 2 times this year. These decisions are made after carefully studying earthquake data, emissions of gas, and changes in the ground. New maps now highlight areas designated as high risk in red and moderate risk in yellow. Routes are decided ahead of time. The goal is to evacuate as many people as possible from dangerous areas before the situation becomes uncontrollable. These plans are detailed and well thought out on paper. Naples is an old city with a layout that shows its long history, not modern emergency preparation. A lot of the streets are small and curvy, and the buildings are close together. Some roads were not built to handle a lot of traffic. If there was an emergency, these streets could easily get blocked. There are only a few highways leading out of the area. These roads are extremely important for people to evacuate. If a volcanic eruption occurs at a bad time, the ash clouds or lava could block these escape routes. The roads that are necessary for safety might not be accessible when they are most wanted. Even with careful preparation, an evacuation would still be disorganized. Panic can easily spread. Traffic jams can form in an instant. Just one closed road can lead to significant delays. Problems with communication can make it more difficult to coordinate. Individuals might pause, uncertain about whether to remain in place or escape. The surface heat found by infrared scanners is very important because it shows more than just scientific interest. It indicates significant changes happening under the city. This information alerts scientists to pressure shifts, gas leaks, and an increase in instability within. The system. The bright spots on the ground are quiet signals that something is wrong beneath the surface. They may not make any sound or cause any physical harm, but they are a clear message to those who can interpret them. Mounting pressure at Campi Flegrei. Scientists don't just study surface-level information. They dig deeper using methods like muon tomography, which tracks cosmic particles passing through rock layers to uncover what lies beneath the ground. By analyzing the behavior of these particles, researchers can identify anomalies like low-density zones that indicate areas of magma or gas-filled cavities pushing upward from a few hundred meters below the surface. Other research teams are also studying the underground system, but they are using different tools. One group is specifically looking at electrical resistivity, which helps measure how easily electrical currents can move through the earth. Solid, cool rock is more resistant to electricity compared to hot, fractured, or fluid-filled ground. The data they gather shows new channels forming below the surface, guiding heat and vapor upward directly beneath Solfatara. With each measurement, the understanding of the underground system improves. Seismic monitoring helps us understand better. There are still small earthquakes happening in the area. Gas emissions are increasing, according to chemical sensors. Thermal cameras show heat spreading on the surface. Imaging tools confirm changes in the structure under the ground. Even though each method works on its own, they all lead to the same conclusion. Campi Flegrei is under critical pressure, and the crust above it is getting weaker. The ground, which used to be stable, is now strained, fractured, and weakened. Scientists are still arguing about specific limits. They are debating the amount of pressure the system can handle and how much heat the crust can withstand. These discussions happen in labs, meetings, and research facilities. But the people living above this system can feel that something is off without needing instruments, as their daily lives show them that something is not right. In houses, there are small but noticeable signs. Bread dough rises too fast in kitchens, reacting to unusual warmth. The tap water runs out warm without the heater on. These things happen frequently in various homes and neighborhoods. Outside, changes are even more evident. Soccer fields feel soft underfoot. The ground gives a little when you step on it, almost like it's breathing. Older people who have been through many earthquakes say that the way the earth shakes has changed. The tremors no longer feel sharp or fast. Instead, they are deeper and weightier. The vibrations have a low, rumbling quality, as if something huge is moving deep beneath the ground. These residents are familiar with earthquakes and can tell when things are different. In coastal regions, fishermen also change their routines. For example, a fisherman in Puzzle always keeps a packed suitcase by the door. This is not due to panic, but as a way of preparing for the possibility of needing to leave quickly. It shows an awareness that swift evacuation might be wanted in the future. The economic impact is already being felt. Real estate prices in high-risk areas have decreased significantly. Houses that used to be valuable are now having difficulty finding buyers. Insurance companies are not willing to provide coverage in these regions because the risk is deemed too great. Fewer people are frequenting local cafes, leading to a drop in business. conversations have shifted from everyday topics to discussing evacuation plans, emergency shelters, and what possessions are most important. Despite all this, life goes on, albeit with a sense of constant apprehension. As people get used to this new way of life, scientists are thinking about what might happen next. The worst-case scenario is complicated, and not just one thing. The Campi Flegrei volcano may not just erupt from one spot. The Earth's crust is splitting in many areas simultaneously. Due to this, some scientific predictions suggest that several openings could appear at once. In this scenario, ash clouds could come up from multiple areas simultaneously. There might be lava shooting up in various parts of the city. Instead of one event spreading outwards, there would be multiple events happening at the same time, each with its own path and power. The city's infrastructure would be in danger right away. Highways might be closed off. Train tracks could be obstructed.